So today we are going to discuss the new topic, that is damped oscillation. Okay. So as you know that simple harmonic motion is an ideal case, because when you have a simple harmonic motion, as you have seen in simple harmonic motion, the total energy of simple harmonic oscillator, that is constant, that is independent on position as well as independent on time. With time, that energy will not be lost, it will be same as it is, and that will be half m omega square a square. But in reality, if you place a simple harmonic oscillator in some medium, in a medium there exist molecules, right? Molecules or atoms. And there's a motion of that simple harmonic oscillator. Suppose you have a spring block system. When it moves in the presence of atoms or molecules, there will be frictional force act in the opposite direction of motion of the oscillator. So as I've seen that initially you have seen that when you have a motion of the body or simple harmonic oscillator, suppose you have a spring block system, there's a restoring force is acting opposite to the direction of motion of the body. But in addition to this, when you have an oscillator is present in some medium, having in a medium, and in a medium there exists atoms or molecules, right? So in addition to restoring force, there will be an additional force will act on the body, and that will be called a damping force. So I will understand this. So suppose you have a let us take a beaker. It contains some viscous, some liquids. Okay, it contains some liquids, and suppose you have some solid body having mass m. You have a beaker. Inside beaker, there's some liquid presence, and inside that liquid there's some solid body. Let us take mass of the body is m. When it's moving downwards, right, there's an upward force will be act on this body, and that is called a viscous force. That will be how much? So you have learned this, right? Like 6 pi, then eta
6
r v, right? Like this. The same is true here also. You have a simple harmonic oscillator. Let us take example of spring block system. And this spring is attached to a wall. Okay. And there exists some, you have kept this oscillator in a medium, right? And in medium, there exists atoms, molecules, and so on. Now, if you displace this block in the right direction with amount x, if you displace this block in the forward direction with amount x, there's a restoring force will act in the opposite direction, right? And that will be how much? That will be minus kx, where k is the spring constant, right? We have displaced x amount, there will be restoring force. Not only that force is acting on this body, in addition to this, there's a frictional force or drag force. That is because of presence of medium having in a medium you have atoms or molecules and so on. So there will be frictional force will act on this body, and that force is opposite to the direction of motion, and that will be called a drag force or damping force FD. So your restoring force is acting in the opposite direction of motion, as well as drag force or damping force will act in the opposite direction of motion, because of there's a frictional force, right, between that block and atoms or molecules, whatever present in a medium. And that force will be what? That will be minus V into V, where B is called, damping or drag coefficient. Drag coefficient. It's called damping or drag coefficient. And V is called what? V is actually instantaneous velocity. Instantaneous velocity. Now net force act on the body or block, that will be how much? That will be minus kx because of spring, and because of this frictional force or drag force, that will be minus b into v, right? And f net means force. Force I can write, that is nothing but mass into acceleration, that will be called del square x by dt square. I'll bring that this term on the right on the left hand side, so that will be, let us write first that this term, so that will be b into v, and that can be written as v is nothing but dx by dt, and you have a last term, that is kx, that will be equal to 0. So this is the differential equation of damped oscillation. This is the differential equation of damped oscillation, and that is arising because you kept your oscillator or of simple harmonic motion in the presence of medium. In the medium, there exist of atoms, molecules, that will make friction, and there will be a drag or frictional force will act in the opposite direction of motion. So net force will contain restoring force as well as drag force. Okay. Now, if you divide, so let us assume this is your equation number 1. Now, if you divide by mass, if you divide by mass, then what will happen? You will have del square x by dt square, and then b by m dx by dt, and then you have k by m, right? X equals to 0. Further, I can write del square x by dt square plus 2 beta dx by dt plus omega naught square x, that is equal to 0. Where I can say that 2 beta is basically how much? 2 beta is nothing but b by m, where beta is called what? This is called damping. This is called damping parameter. And हाँ जी बताओ,
ये कांस्टेंट लिखते टाइम हम 2 का फैक्टर क्यों इंट्रोड्यूस करते हैं?
to make that calculation simple, to make that calculation simple. To make that calculation simple, nothing. So then you have a omega naught square, and that will be how much? Omega naught, how will define? Omega naught is nothing but k by m. And omega naught is basically called what? Omega naught को क्या बोलते हैं हम? बताओ.
Natural frequency.
There will be natural frequency.
Angular frequency.
This is called natural frequency. Okay, and let us give that or number that this differential equation. This is your equation number 2.
सर नेचुरल फ्रीक्वेंसी से मतलब जिस फ्रीक्वेंसी से वो ऑसिलेट करेगा जब कोई पार्टिकल नहीं होंगे या
Exactly.
फिर ओके ओके
Okay. So now let us assume that solution of this differential equation, solution of, assume the solution of, okay, solution of equation number 2 is xt equals to a e the power alpha t. So this is basically second order differential equation, right? So I'm assuming that solution of this differential equation is a e the power alpha t. Now if you substitute this here, what will happen? So x is this much. If you differentiate this with respect to time 2 times, then how much you will get? In the first time you have what? Del square x by dt square. Ji, bolo.
The first one is alpha square.
Exactly. Puneet, your voice is, so low. Cannot audible.
Sir, am I audible now?
Now, yes.
Yes, sir. So I was saying that it will be alpha square
Exactly. So if you substitute it,
plus 2.
so you'll have alpha square. I'll take that a into e the power alpha t. हम कॉमन लेंगे इसको. आप बताइए इस टर्म में क्या आएंगे और आप पहले सब्स्टिट्यूट कीजिए इसको.
अल्फा स्क्वायर प्लस 2 बीटा
अल्फा स्क्वायर a e the power alpha t, है ना? If you differentiate this with respect to time 2 times, you will get alpha square a e the power alpha t. Then 2 beta alpha e the power alpha t, right? And in the last term you have simply omega naught square a e the power alpha t, that is equal to 0. Now you can take a e the power alpha t common, and then you will have alpha square plus 2 beta alpha plus omega naught square, that is equal to 0. That is equal to 0. Okay. So this is amplitude, and e the power function can never be 0, right? So we like this is on factor, and the factor is this. This factor cannot be 0. There's some kind of amplitude, and exponential function can never be 0. So it means basically this factor will be 0. Product of two factor is 0. It means what? This can be. It cannot be 0.
term only can be 0.
It cannot be 0. This amplitude and exponential function can never be 0. It means only this function will be 0. So we substitute alpha square plus twice beta alpha plus omega naught square, that is equal to 0. So the quadratic equation, right? Now we can find that root. So alpha will be how much? Alpha क्या आएंगे बताओ? So that will be minus twice beta plus minus, then क्या आएगा? So as you know, right? So you have alpha x square plus beta x plus gamma equals to 0. Then x is how much? X कितना होता है? Minus beta plus minus
Beta square minus 4 alpha.
minus 4 alpha gamma divided by 2 into alpha. Same I'll apply here. Now this is the quadratic equation of what? This is the quadratic equation of alpha. So alpha will be what? Minus 2 beta, then 4 beta square minus what? 4 gamma, sorry, omega naught square, right? और क्या आएंगे यहाँ पे बताइए जरा.
Upon 2 आएगा सिर्फ.
2, right? So यहाँ से alpha आ जाएगा. You will have two root. One will be alpha 1, है ना? यहाँ पे दो रूट आएंगे, एक तो प्लस एक अपॉन माइनस. तो अल्फा 1 will be how much? 2 तो कैंसिल हो जाएंगे. देखो ये आपका 4 स्क्वायर रूट ऑफ 4, इसको बाहर लेके आ जाओ तो 2 आ जाएगा, and you will have 2 common, and that will be cancelled. So alpha 1 I can write that will be minus beta plus beta square minus omega naught square, and you'll have another root that will be alpha 2, that will be minus beta minus square root of beta square minus omega naught square. So you'll have basically two roots. Now I'll get the general, I'll get a solution of differential equations. So I have basically two roots here, alpha 1 and alpha 2. You have this is your differential equation. You have assumed that solution is that. But when you are substituting, you are getting two roots, alpha 1 and alpha 2. So what will be the solution actually? क्या solution आएंगे बताओ?
C1 e raised to alpha t plus C2 e raised to minus alpha t.
So it will you will get that solution xt, that will be how much? That will be a on e the power alpha on t plus a2 some other constant into e the power alpha 2 t. So I'll substitute that values. So you'll have a on, then e the power alpha 1 is how much? Minus beta, then plus beta square minus omega naught square, right? And then t, and then you have a2 some constant into e the power minus beta square minus omega naught square into t, right? So this is the solution. You can get on factor common, that will be what? क्या common आएंगे यहाँ से बताइए? What will get common? So you can see from here in the both term you have e the power minus beta into t. So I can get e the power minus beta into t, that will be common, and then you have a on e the power क्या जाएगा? It will be beta square minus omega naught square t, and a2 e the power minus beta square minus omega naught square into. Now there are basically four different, depending upon that strength of damping parameter, depending upon that value or strength of damping parameter, there will be basically four different cases. Okay, so we'll discuss one by one. So this is the basically this is the general solution. This is the general solution of damped oscillator or damped oscillation, that will contain e to the power minus beta t, a1 is some constant, e to the power e to the power square root of beta square minus omega naught square t, and you'll have second term a2 some other constant, e to the power minus square root of beta square minus omega naught square into t. This is the general solution of any damped oscillation. Now there will be different cases, right? There will be four different cases depending upon the strength of damping parameter. Okay, so we'll there will be four cases. We'll discuss one by one. So we'll have four cases here. So case number one, when beta equals to 0, when beta is equals to 0, then what will be called it? Beta जब 0 हो जाएगा तो फिर क्या केस आ जाएगा बताओ? Exactly, this will be the simple harmonic motion. So when you have a beta equals to 0, then what will happen? You will get oscillation in the body. You will have oscillation, and this is called basically what? This is called simple harmonic motion. Actually, simple harmonic motion is the ideal case. In reality, whenever you will place that your spring block or any simple harmonic motion system in a medium, there will be some frictional force or drag force will act in the opposite direction. Okay, so beta equals to 0 is the reality. I mean, it is the ideal case. It will convert it to simple harmonic motion. In simple harmonic motion, you know there is a oscillation. Then you have a second case when beta is non-zero actually, but strength is low. Beta square is less than omega naught square. Strength is low as compared to natural frequency. तो इसको अगर बीटा का वैल्यू सब्स्टिट्यूट कर दोगे आप तो फिर क्या आ जाएगा बताओ? बीटा एंड ओमेगा नॉट. You know beta will be how much? You have defined 2 beta, right? 2 beta was how much? That is b by m. Now if I substitute that beta value, and also you have defined, right, omega naught square क्या define किया था आपने? K by m. If you substitute it here, both, you will get this condition: b square less than 4mk. B square less than 4mk, that will obtain. In that case, again, in that case, you will get oscillation. Oscillation means what? You will have to and fro motion in the body when that strength of damping parameter is low as compared to natural frequency. I mean, beta square less than omega naught square, or this condition. There will be oscillation in the body, and that oscillation will be called halt. क्या बोलते हैं इसको? Since damping parameter is low, that's why it is called under damping. Under damping. This is called under damping because damping parameter is low here. But still, there will be oscillation in the body. Oscillation means there will be to and fro motion. But in this case, energy will be constant over the time. We'll see. But in that case, there will be decay of energy of oscillation, because whenever you have a friction in the body, what will happen? The energy will be lost in the form of heat or in other form. So that's why, although there is a oscillation in the body in second case, still there will be a loss in the energy. Energy will be decay in exponential form. But in this first case, energy will always be constant with time and with space. Then you have a third case. What is third case? When beta square equals to omega naught square, which implies in terms of drag coefficient की form में क्या आ जाएगा? That will be when b square equals to 4mk. So in this case, when now you are increasing that strength of damping parameter. So now when they are approaching, both are same, or this condition when you are achieving, in that case there will be no oscillation in the body. We'll see actually there will be no oscillation in the body.
So beta equals to 4k ना?
हाँ जी, 4k होंगे या 4m के होंगे, बताइए. जैसे ये कितना आ जाएगा आपका, बताइए. b स्क्वायर क्या लिखेंगे आप? b स्क्वायर बाई 4m स्क्वायर लिखेंगे आप, राइट? और ओमेगा नॉट स्क्वायर कितना है आपके पास? k बाई m है. एक m कैंसिल हो जाएगा, एक m रह जाएंगे, राइट? वो आपका उधर चला जाएगा, राइट? हाँ. So in that case there will be no oscillation in the body, and this case is called what? इसको क्या बोलते हैं, बताइए, कंजन बताइए, क्या बोलते हैं इसको?
Critical damping.
Exactly, this is called critical damping. This is called critical damping. And you have a last case, that is when beta square greater than omega naught square.
Overdamp.
This is in or beta square greater than 4mk. So in that case also we'll see there will be no oscillation in the body. There will be no oscillation in the body, and this is called what? This is called overdamping. Exactly. So आपका एग्जाम पॉइंट ऑफ व्यू के लिए कौन सा ज्यादा इंपॉर्टेंट है जी? कोई बता सकते हैं?
क्रिटिकल डैम्पिंग.
हम हाँ जी बताइए.
So critical damping ज्यादा important है.
Beta square less than omega naught square.
Exactly.
I think under damping.
We'll learn every system, but आपका एग्जाम में जो आएंगे सारे क्वेश्चन आपका बेसिकली अंडर डैम्पिंग से आते हैं. We'll see on by on.
सर.
हाँ जी बताइए.
सर जो अपना जनरल सॉल्यूशन था उसमें जो एक्सपोनेंशियल दोनों टर्म्स थे वो ऑसिलेटिंग टर्म्स है, बराबर?
हाँ.
तो अभी थर्ड केस में बीटा स्क्वायर इज इक्वल टू ओमेगा नॉट स्क्वायर हो गया, तो वहां पे x ऑफ t सिर्फ एक ही टर्म बचेगा, e टू द पावर माइनस
अभी हम देखेंगे ना,
वहां से बता सकते हैं कि ऑसिलेशन नहीं है.
एग्जैक्टली
फोर्थ केस में तो वो टर्म्स बचेंगे ना सर?
अभी चलेंगे, अभी एक एक करके डिस्कस करेंगे जी, हर एक टर्म को डिस्कस करेंगे. अभी पेशेंस है ना, अभी हर एक टर्म को डिस्कस, हमें बताया ना, हम हर एक टर्म को डिटेल्स में देखेंगे कि क्यों ऑसिलेशन नहीं होगा, है ना जी. डोंट वरी. हाँ जी ठीक है. अब हम एक एक करके डिस्कस करते हैं, ठीक है. सो फर्स्ट क्या केस था आपका? एज यू रिमेम्बर, यू हैव ए जनरल सॉल्यूशन जो था डैम्प्ड ऑसिलेटर का, क्या था? e the power minus beta t, right? And then you have a on e the power, क्या था जी यहाँ पे बताइए, बीटा स्क्वायर माइनस
omega naught square.
t, then you have second term a2 e the power minus beta square minus omega naught square. In the first case, I'll discuss one by one. In the first case क्या था आपका बताइए, beta is equals to what? 0 था, right?
0, sir.
Okay, now if you substitute here in general equation, what will happen? Now tell me, what will be xt here? So this term e the power minus 0, no, that will be on, right? So you'll have a on some constant, and then this will be 0. So minus square root of minus omega naught square, क्या आ जाएगा? Square root of minus
I omega.
Exactly, it will be square root of minus 1 means
I
what?
omega naught, sir.
Exactly, so it will be I omega
Omega
naught
naught.
t, and then you have a second term a2 e the power minus I omega.
Again, I omega naught.
ठीक है? Now you know that e the power I theta क्या आता है बताओ? E the power I theta is nothing but cosine theta plus
I cos theta plus I sin theta.
I sin theta. So I'll substitute here. If you substitute it here, tell me how much you'll get. So in place of e the power I omega t, I'll write cosine omega naught t plus I sin omega naught t. In place of e the power minus I omega naught t, what I'll write cosine omega naught t minus I sin omega naught t. है ना? तो आपका दो कोसाइन का टर्म रहेंगे, एक आपका साइन का टर्म रहेंगे, राइट? इफ यू कंबाइन, अगर आप यहाँ पे एक कोसाइन का टर्म मिलेगा, यहाँ पे एक कोसाइन का टर्म मिलेगा, अगर दोनों को आप कंबाइन करेंगे क्या मिलेगा बताइए? a on plus
A2 cos omega naught t.
Exactly, cosine of omega naught t. And then again you will have two sine term as well, right? You'll have
I a1 minus a2.
Exactly, so you'll have I a on minus a2 and sine of omega naught t. ठीक है? Now can you tell me that this will represent simple harmonic motion? Can you please tell why this will represent simple harmonic motion? So this is a constant, right? The constant I can represent this like c, and I can take this as another constant d, because this is independent on time, it's a constant, right? So I can represent like c cosine of omega naught t, and then you have d sine of omega naught t. This is representing simple harmonic motion. Can anyone tell me why? This is representing
Because
cos omega t और sin
superposition
omega
of-
t है ना? Oscillator होते हैं वो.
पुनीत को छोड़ के बताओ, कंजन बताओ, क्यों ये रिप्रेजेंट कर रहे हैं आपका सिंपल हार्मोनिक मोशन?
cos सॉल्यूशन जो हमने देखा था x is equal to a cos और sin omega t होता है सिंपल हार्मोनिक का.
कंडीशन क्या है? कोई भी
अरे।
इक्वेशन को सिंपल
Sir,
हार्मोनिक
it is periodic. Periodic.
एग्जैक्टली
ओमेगा नॉट
नहीं, आपको कंडीशन क्या है सिंपल हार्मोनिक मोशन के लिए? फॉर एसएचएम कंडीशन बताओ, क्या कंडीशन है? दैट
ओमेगा नॉट
एक्सीलरेशन प्रोपोर्शनल टू व्हाट?
Displacement
Minus x. Minus x.
minus
एक्सीलरेशन प्रोपोर्शनल टू माइनस एक्स. क्या यहाँ से आएंगे एक्सीलरेशन प्रोपोर्शनल टू माइनस एक्स?
नहीं, sir.
आएंगे कि नहीं?
आएगा सर.
आएगा, राइट? सो दिस इज रिप्रेजेंटिंग सिंपल हार्मोनिक मोशन. ये भी कभी एग्जाम में पूछा जा सकता है कि आपको सपोज मान लो आपको ये दे दिया कि सॉल्यूशन ऑफ ए इक्वेशन इज गिवन एज a ln ओमेगा t, है ना? और आपको पूछा जा सकता है क्या ये सिंपल हार्मोनिक मोशन को रिप्रेजेंट कर रहा है? क्या ये
No, sir.
No,
No.
it will not represent simple harmonic motion. So simple harmonic motion के लिए आपको हमेशा क्या होना चाहिए? Acceleration proportional to minus 6. That you have to keep in mind. So this will represent simple harmonic motion. है ना? सपोज मान लो यहाँ पे 2, अगर मैं थोड़ा मॉडिफाई कर देता हूँ, सपोज मान लो यहाँ पे ट्वाइस ओमेगा नॉट टी आ गया, तो अगर 2 आ जाता, क्या ये सिंपल हार्मोनिक मोशन को
No.
रिप्रेजेंट? नो.
No, sir.
No.
So you have to keep in mind that for simple harmonic motion, acceleration should be proportional to minus of displacement. So that's why it is satisfying that condition of SHM. है ना?
No.
Hmm.
So,
बताइए।
from last third step, I did not get it.
कोई ये या जब यहाँ पे 2 लगा देंगे
No, sir. From last third step, I'm not getting it.
लास्ट
Third step.
दिस
Yes, sir.
हाँ
When you put value beta equals to 0,
if you substitute beta equals to 0 here, yes, if you substitute beta equals to 0, what will have? Will have minus square root on कितना होता है बताइए, माइनस स्क्वायर रूट ऑन कितना होता है बताइए,
I
होती है एग्जैक्टली है ना। तो यहाँ पे बीटा इसका 0 है, यहाँ पे स्क्वायर रूट ऑफ माइनस ऑन को क्या लिखेंगे आप?
you have written I omega t.
हाँ
I
विल हैव
forget
ओमेगा
it.
नॉट
Sorry, sir.
स्क्वायर ना,
Yes, sir.
ओमेगा नॉट स्क्वायर का ओमेगा नॉट आ जाएगा, माइनस ऑन का स्क्वायर रूट आई आ जाएगा, आपके पास टी ऑलरेडी है, यहाँ पे माइनस है और माइनस स्क्वायर रूट माइनस ऑन के कारण ओमेगा सॉरी आई नॉट आ जाएगा, ओमेगा नॉट स्क्वायर का स्क्वायर रूट ओमेगा नॉट और टी आपके पास है। और फिर इसको एक्सपोनेंशियल आई थीटा को आप ये करो, एज यू नो ई दी पावर आई थीटा क्या होता है आप बताइए, ई दी पावर आई थीटा कितना होता है जी बताइए आप?
Cos theta.
हाँ कोसाइन ऑफ
Cos
प्लस आई
theta.
साइन ऑफ
I sin theta.
थीटा। तो यहाँ से जब जस्ट आप सब्स्टिट्यूट कर दीजिए आप, कोसाइन ऑफ ओमेगा नॉट टी प्लस आई साइन ऑफ ओमेगा नॉट टी, here we'll have cosine of omega naught t minus I sin of
Minus I sin of omega.
ठीक है ना जी। अब कोसाइन का 2 टर्म मिलेगा, एक यहाँ से और एक यहाँ से, दोनों को मर्ज कर दीजिए, a1 प्लस a2 कोफिशिएंट मिल जाएगा, साइन का भी 2 टर्म आएगा है ना, उसको आप ऐड कर दीजिए, आपको ये आ जाएगा कोफिशिएंट।
Sir, in the last step that you were explaining, please.
हाँ
explain that
दैट
also.
दिस इज ए कांस्टेंट राइट, a1 प्लस a2 को मैंने एक कांस्टेंट ले लिया सी,
Yes, sir.
एंड आई a1 माइनस हाँ a2 को आप मैंने डी ले लिया, डी
D.
कांस्टेंट।
Okay.
So this is, I mean, when that beta is 0, that is representing simple harmonic motion, and you know, in simple harmonic motion, condition is that acceleration proportional to displacement, and in simple harmonic motion, energy is constant over the time and space. Now you have a second case. Now you have a second case, case number 2, that beta naught square is omega naught less than omega naught square. ठीक है? So as you know, you have a square root of क्या है आपका बीटा स्क्वायर माइनस ओमेगा नॉट स्क्वायर, ये है आपका इस सिंपल हार्मोनिक आई मीन जो जनरल जो सॉल्यूशन है, इन दैट जनरल सॉल्यूशन यू विल हैव स्क्वायर रूट ऑफ बीटा नॉट स्क्वायर माइनस ओमेगा नॉट स्क्वायर, ठीक है ना। अब मैं क्या करूंगा, I'll assume that some omega on square that is equals to omega naught square minus beta square. I'll assume some frequency omega on square that is equals to omega naught square minus beta square, and I'll substitute this in your general equation. If you substitute this omega on square in your general equation, now tell me what will happen if you substitute it in your general equation. बताइए क्या आएंगे, साइन बताओ, what you will get if you substitute this? I have defined some. So first you will have e to the power minus beta into t, and then you'll have a on, then क्या आएगा बताओ? So you have, if you substitute it carefully, हाँ अगर आप if you substitute it carefully, you'll have e to the power I omega on t, and then the second term e to the power a2 e to the power minus I omega on t. चेक कीजिए जरा,
Yes, sir.
everybody is getting this?
Yes.
Substitute this.
Yes, sir.
You are getting right. So you will have e to the power minus beta t, a1 e to the power I omega on t, a2 e to the power I omega minus I omega on t, and a1 and a2 क्या है यहाँ पे? What is a1 and a2? They are basically constant, right?
Yes.
a1 and a2 that is constant. So for sake of simplicity of our calculation, I'll assume that constant a1, I'll assume that will be some other constant a by 2 है ना, I am assuming this is a constant, that constant I am assuming some constant a by 2 with some phase factor e to the power I theta, and similarly I'll assume a2, that will be a by 2 e to the power minus I theta.
सर A1 A2 हमारे कांस्टेंट्स है ना, तो
हाँ
उसमें
constant, this is
क्या कैसे
initial,
ले सकते हैं
this
हम?
is initial phase, this is some initial phase,
Okay, so it is that angle is constant.
this is constant, initial phase
Theta is constant.
constant. This is not theta equals to omega t, not like that. This is theta is some initial phase. This is a constant. Now if you substitute it here, can you please tell me what will be the form now? अगर इसको substitute करेंगे आप, बताइए, साइन बताओ. When you substitute it, I mean a1 here and a2 here, what will have? You'll have solution xt, that will be e to the power minus beta t, and then you'll have a into e to the power I omega on t plus theta. I omega on t plus theta. So you'll have a e to the power क्या आएगा? I omega on theta plus a e to the power minus I omega on t plus theta divide by 2. हाँ, you can take a common, यहाँ पे भी a है, यहाँ पे भी a है. You can bring that a outside. And what is this actually? E to the power some I into some angle, e to the power minus
Step for theta.
cosine, right?
सर ये A1 A2 को ऐसा क्यों लिखा, कैसे लिखा?
a on a2 को मैंने define किया. a on जैसे आपका ये a1 क्या है? This is some constant, right? So I have defined a on is a by 2 e to the power I theta, है ना? जहाँ पे theta क्या है? Initial phase है. ठीक है?
Okay.
And a2 is some other constant a by 2 e to the power minus I theta.
सर पर हमें ये कैसे पता कि ये एक्सपोनेंशियल
For the sake of simplicity of your calculation. Okay, now if you you have, this is your like a cosine function, right? So now you can see you will have a e to the power minus beta t, and then you have cosine of omega t plus theta. Now tell me what you can infer from here. What you can infer from here?
The amplitude is decaying.
You can see it contains in general solution. In the solution, it contains two factors. One is this is cosine function. This is actually what? This is oscillating in nature. This is an oscillating function, right? Cosine, sine, this function are basically oscillating in nature. And what is this actually? ये क्या represent कर रहा है?
Amplitude.
This is actually
Amplitude.
this is an exponential decay, right? The exponential decay. So oscillating function, when it contains oscillating function, it means what? You'll have oscillation in the system with time. With time, there'll be oscillation of the body, no doubt. But this exponential decay, what does it representing? That amplitude of oscillation is no longer constant, but there will be decay over the time. There will be decay of the amplitude of oscillation in underdamping case, but still there will be oscillation in the body. So now if you represent it, how will you represent that? So this side, you have a time, and this side you have a displacement x, and this is a mean position. The mean position. Now suppose you have a spring block system in underdamping case. You're displacing your block from mean position to some amplitude a. Now what will happen? Tell me. मीन पोजीशन से आपने कितना डिस्प्लेस किया, ए अमाउंट डिस्प्लेस किया. What kind of nature or oscillation it will follow? So it will be like it will be oscillating, but amplitude will be decay. So when you displace that body up to A, there will be oscillation in the body. So ये वाला जो part है क्या represent कर रहे हैं बताइए. First of all, this curve is representing what? This is a oscillating function that will be cosine of omega on t plus theta. And what about this? ये क्या represent कर रहा है बताओ. This is your a to the power minus. So your amplitude you see, amplitude means maximum displacement. Maximum displacement is actually decreasing exponentially over the time. But you see, there is a to and fro motion, right? To and fro motion means what? There's an oscillation in the body. So in underdamping case, there will be oscillation, but amplitude will be decay, or there will be exponential decay of amplitude. And this amplitude, how you can represent that amplitude? कैसे represent कर सकते हो बताओ? If you represent amplitude over time, so there will be exponential decay, right? There will be exponential decay. So it will be a maximum amplitude when time is 0. So basically, the really important for your exam that amplitude of underdamping case, that will be initial amplitude e to the power minus beta t. Now, if amplitude is following like this, now can you tell me how the energy will behave with time? How energy will change with time?
Exponentially decreasing.
Half
in
omega
minus
square
two.
So as you know that energy proportional to actually what? Energy is proportional to amplitude square, right? Energy is proportional to amplitude square. You have seen that. So if you substitute that energy proportional to amplitude square, what will obtain actually? That energy at a time in the oscillator, that will be what? E naught. अब क्या आ जाएगा यहाँ पे बताओ? Factor. That will be
Not 0 square e raised to minus 2.
minus 2. Okay. So how will represent that? You'll have energy in the oscillator. With time, it will decrease. So this is your E of t. But why that energy is decreasing? Energy should be conserved, right? Why the energy is decreasing?
Damping is there.
Why that? Where is the energy is going then? जो आपका एनर्जी था सिंपल ऑसिलेटर में कहाँ जा रहा है वो एनर्जी?
Energy is proportional to.
सर वो डिसिपेट हो जा रहा है एनवायरनमेंट में.
Exactly, it is dissipating. It is dissipating. It is taking other form, right? So this is your case, like you have a damped, under damping case. Okay. Now let us solve one problem, then we'll proceed for next case. तो सपोज आपका एक अंडर डैम्पिंग केस है, एक अंडर डैम्प्ड ऑसिलेटर है और 100 साइकिल कंप्लीट होने के बाद 100 साइकिल कंप्लीट होने के बाद उसका जो एम्पलीट्यूड रिड्यूस हुआ है, दैट इज रिड्यूसेस टू हाफ ऑफ इट्स इनिशियल वैल्यू. You have a under damped oscillator. After completing 100 cycle, the amplitude reduces to half of its initial value. Now tell me, what will the amplitude of oscillator after completing 200 cycle? 100 साइकिल कंप्लीट होने के बाद एम्पलीट्यूड कितना हो गया? इनिशियल एम्पलीट्यूड का आधा हो गया. आपको पूछा क्या गया है, व्हाट विल द एम्पलीट्यूड आफ्टर कंप्लीटिंग 200 साइकिल?
1/4.
1/4. how you are doing?
A equal to A naught exponential minus
हाँ, so
and A is replaced by A naught by 2. A naught get cancelled. That will be
so as you know that a of t, that is how much? A naught e the power minus beta into t, right? So अब बताओ 100 साइकिल 100 साइकिल्स कंप्लीट होने के लिए कितना टाइम लगेगा? कितना टाइम चाहिए बताइए? 100 साइकिल के लिए, एक साइकिल के लिए कितना टाइम लगता है? ऑन साइकिल के कॉरस्पॉन्डिंग
20.
टाइम कितना है? दैट इज कॉल्ड टाइम
20.
पीरियड. दैट इज कॉल्ड
100 for
एक साइकिल के लिए जो टाइम
100.
लगता है रिक्वायर, दैट इज कॉल्ड टाइम पीरियड. तो 100 साइकिल के लिए जो टाइम लगेगा दैट विल बी व्हाट? दैट विल बी
100t.
100t.
100t. I mean, I can write that A of 100t, that will be how much? That is given A naught by 2. That is equals to how much? That is A naught e the power minus beta into or 100 beta t. यहाँ से A naught कैंसिल हो जाएगा. इसका मतलब आपको पता चल गया कि e the power minus 100 beta t जो है that is nothing but half. That is nothing but half. Now you have to calculate when t equals to 200 साइकिल में टाइम कितना लगेगा? That will be 200 into t. एक साइकिल के लिए t टाइम, कैपिटल t टाइम लगता है, 200 के लिए 200 into t लगेगा. So now that amplitude after completing 200 cycle, that will be time 200 into t, that will be how much? So you'll have a naught into e the power what? E the power minus 200 beta into t. And that can be written as a naught e the power, इसको क्या लिख सकते हो बताओ? e the power 100 beta t का स्क्वायर, e the power 100 beta t का स्क्वायर लिख सकते हो, right? Am I correct? And you have obtained this e the power minus 100 beta t का वैल्यू कितना आपको मिला है? That is half. You have obtained half. So half का स्क्वायर, right? Is it clear ना? A naught e the power minus 200 beta t. Further you can write e the power minus 100 beta t का स्क्वायर लिख सकते हो आप. और इसका वैल्यू आपने ऑलरेडी कैलकुलेट किए हो. e the power minus 100 beta t का वैल्यू कितना है? That you have obtained, that is half. So you have a half का स्क्वायर into a naught. So that will be a naught by 4. So after completing 200 cycle, or the amplitude that will be reduces to 1 by 4 times of its initial value.
सर
बताइए
सर
जी.
ये जो आपने a इक्वल्स टू 100t वाला जो स्टेप एक्सप्लेन किया, a by 2 इक्वल्स टू, ये वाला स्टेप एक बार प्लीज रिपीट कर देंगे?
ये वाला
उसके नीचे
इसका नीचे वही
a
तो,
इक्वल्स टू 100t इक्वल्स टू वो वाला सर.
ये वाला.
हाँ सर.
हाँ, इसमें क्या बोला गया है कि जैसे आपका कि एम्पलीट्यूड जो अंडर डैम्प्ड ऑसिलेटर का 100 साइकिल कंप्लीट होने के बाद उसका एम्पलीट्यूड कितना हो रहा है? हाफ ऑफ इट्स इनिशियल वैल्यू. ठीक है. एक साइकिल कंप्लीट करने के लिए कितना टाइम लगता है? एक साइकिल कंप्लीट करने के लिए जो टाइम लगता है ना, ऑन कंप्लीट साइकिल के लिए जो टाइम लगता है, दैट इज कॉल्ड टाइम पीरियड. दैट इज नोटेड एज कैपिटल टी, है ना. एक कंप्लीट साइकिल के होने के लिए जितना टाइम लगता है दैट इज कॉल्ड कैपिटल टी. तो एक साइकिल के लिए कैपिटल टी टाइम लगता है, तो 100 साइकिल कंप्लीट करने के लिए कितना टाइम लगेगा?
t into 100.
t into 100. तो ये तो कोई आर्बिट्ररी टाइम, दिस इज द एम्पलीट्यूड फॉर एनी आर्बिट्ररी टाइम. Amplitude of oscillator after time t, that will be a naught e the power minus beta t for any arbitrary t. Now amplitude of oscillator after this time what will be happen? So t के जगह पर कितना रख रहे हो आप? 100t, because ये आपको पता है a of 100t amplitude after 100 cycle that is provided a naught by 2, है ना. और t के जगह पर कितना रखोगे आप? 100 बीटा. 100 t के जगह पे कितना रखोगे? 100 into t रखोगे यहाँ पे. So you'll have a
in
naught.
place of t will put.
हाँ, यहाँ से आपका a naught कैंसिल हो जाएगा और e to the power 100 minus 100 बीटा t का वैल्यू आ जाएगा हाफ. आपको पूछा क्या गया है? 200 साइकिल कंप्लीट होने के लिए कितना 200 साइकिल कंप्लीट होने के बाद कितना एम्पलीट्यूड होगा, तो टी के जगह पे कितना
That
रखोगे?
part is clear.
हाँ
200. That part is clear.
कितना ही है. नाउ यू हैव ए थर्ड केस. थर्ड केस क्या है? केस नंबर 3, when beta square equals to omega naught square. Now tell me what will happen. When beta square equals to omega naught square. Now if you substitute that beta square equals to omega naught, what will happen? बताइए जरा. We substitute that beta square equals to omega naught square. क्या आएगा आपका बताइए जरा.
So e to the power minus beta t.
E to the power minus beta t and then
a1 plus a2.
a1 plus a2. So that is a1 plus a2 some constant c to the power minus beta t. Now tell me, is there any oscillation in the body? Is there any oscillation in the body? No. There is no oscillating function contained in this solution. You do not have any oscillation here, right? So it doesn't contain any oscillation term here. So there will be no oscillation in the body for this scenario. There will be no oscillation in the body. Now I have a last case. That is what? Beta square greater than omega naught square. Now if I ask you to define some omega 2 square, can you please define? इसको कैसे define करेंगे बताइए जरा, है ना. प्रीवियस केस को थोड़ा सोच के आप इसको डिफाइन कीजिए. हाँ जी.
ठीक उसका उल्टा जो पहले
beta square minus naught square.
Beta square minus omega naught square. Now if you define, now can you please tell me that what will be xt now? So you'll have what? You'll have minus beta t and then a on e the power क्या आएगा?
omega
beta square minus omega naught square.
That you have defined, right? Omega
Yes, sir.
2 per square. So you have omega 2t and then second term you'll have a2 e the
Minus
power
omega 2t.
omega 2t. Now if you bring this term, inside bracket, what will happen? A on e the power क्या आ जाएगा बताओ? Can I write like this?
e to the power omega 2 minus
Beta minus omega 2 t. And then you have a2 e the power minus beta plus omega 2 t. अब बताओ ये टर्म क्या है, पॉजिटिव है या नेगेटिव है? बीटा माइनस ओमेगा 2.
Positive.
दिस इज पॉजिटिव, राइट? सो ई दी पावर ये क्या रिप्रेजेंट कर रहे हैं फर्स्ट टर्म?
exponential decay.
Decrease.
दिस इज आल्सो
Exponential decay.
व्हाट इज द मीनिंग ऑफ दैट? यहाँ पे कोई ऑसिलेटिंग टर्म नहीं है, राइट?
Sir,
लास्ट
yes,
केस. हाँ जी बोलो.
sir,
हाँ जी बताइए.
beta greater than omega naught. Beta is not greater than omega 2.
नहीं यहाँ से बताइए ना, यहाँ से देखिए आप. बीटा स्क्वायर विल बी व्हाट? इट विल बी ओमेगा 2 स्क्वायर प्लस ओमेगा नॉट स्क्वायर.
Oh,
ओमेगा 2 स्क्वायर इक्वल्स टू व्हाट? बीटा स्क्वायर माइनस ओमेगा नॉट स्क्वायर, राइट? It means
okay.
beta square will be what? Omega 2 square plus
Beta
omega
greater
naught
than
square.
omega 2.
So
Okay.
obviously beta greater than omega 2. So
Okay.
in the beta greater than omega 2, this will be representing what? This will be exponential decay. And this is also exponential decay, but there is no oscillation term in the solution. So again, there will be exponential decay of amplitude, but there will be no oscillation in the body when there is overdamping in the system. When you have overdamping in the system, there will be no oscillation in the body. Okay, now I'm giving one problem. Please try to solve that question, है ना? इसके बेस पे आपका एक क्वेश्चन आता है ना? That you can solve by using जो आपका मैथमेटिकल फिजिक्स में भी जो पढ़ते हो ना, डिफरेंशियल इक्वेशन, उसके बेस पर भी सॉल्व कर सकते हो, और बाय यूजिंग दैट डैम्प्ड ऑसिलेशन सॉल्यूशन उसके बेस पर भी सॉल्व कर सकते हो, है ना? सपोज आपको एक डिफरेंशियल इक्वेशन गिवन है. सपोज दैट डिफरेंशियल equation of damped oscillation is given. That is del S square x by dt square plus 2 dx by dt plus 10x equal to 0. और यहाँ पे गिवन है कि x of 0 equals to 4 and x dot 0 equals to -4. Boundary condition given है. The differential equation given for damped oscillation. इस तरह की प्रॉब्लम बहुत ही ज्यादा इंपॉर्टेंट है आपका एग्जाम पॉइंट ऑफ व्यू के लिए. यू कैन यूज मैथमेटिकल टूल ऑफ मैथमेटिकल फिजिक्स और यू कैन यूज कॉन्सेप्ट ऑफ डैम्प्ड ऑसिलेशन, है ना. और आपका बाउंड्री कंडीशन गिवन है x0 equals to 4 and x dot 0 equals to -4. So what you have to find? You have to find x dot. ये आपको फाइंड करनी है ना. इसको सॉल्व कीजिएगा, है ना. दिस इज योर होमवर्क.
इक्वल टू 4 है ना.
x0 equals to 4, x dot 0 equals to -4.
यस.
Okay, please try to solve this question.
Sir, and
हाँ
we
जी,
have to
बताइए.
find xt, ना?
You have to find xt. You have to देखो यहाँ पे आपका दो कंडीशन गिवन है, वहां से आपका a1 एंड a2 का वैल्यू आ जाएगा. दो अननोन क्वांटिटी है ना, a1 एंड a2. जो जनरल सॉल्यूशन है वहां पे क्या है, दो अननोन क्वांटिटी है. एक आपका a1 अननोन है और एक आपका a2 अननोन है. बाकी आपका बीटा ओमेगा नॉट यहाँ से आ जाएगा. बीटा ओमेगा तो यहाँ से ही आ जाएगा ना. तो a1 and a2 you will obtain from these two boundary conditions. Okay, so please try to solve this question. Tomorrow we'll solve few problems and we'll go important topic, that is Lissaj's figure. So we'll not solve anything, just from basic tool we'll understand how without memorize anything you can draw that Lissaj's figure. So tomorrow we'll discuss that part.
Sir, we
Yes.
don't have any material to practice.
Yes, we have materials. Satish sir didn't provide you?
Sir?
ना सर.
Okay, I'll ask to Satish sir. We have materials. So many problems are there.
Yes, sir.
I'll ask. Okay. Okay, then we'll see tomorrow that Lissaj's figure, and some few problems we'll solve. Okay then.
Thank you, sir.
Sir.
Thank you, sir.